Okay, are you excited? I'm excited. We are at the end of activity 16. This is activity 16.4. We are looking at the problems 4 through 9. I'm going to kind of run through the answers, and then I'm going to give you your homework assignment, okay? So we're looking at pages 233 through 234 in your PDF file. Number 4 basically says, hey, how do we prove this shape they give us is a rectangle? And what they gave us was an equilateral shape, meaning a rhombus. Okay, and so, I'm sorry, not prove it's a rectangle, prove it's a square. If they give you a rhombus, you need to prove it's a rectangle, because remember, a square is simply a rectangular rhombus, or a rhombus that also happens to be a rectangle. So if they tell you it's a rhombus and say, could we prove it's a square, then we need to prove that it's a rectangle. So they asked for two different ways. We use from 16.2. 16.2 is about rectangles, so you can go back and watch the video if you'd like. But the two main ways to prove that something is a rectangle: the diagonals are congruent, or that there exists a singular right angle, because if there is one, there are four. So that's what they're looking for in number 4. Number 5, 6, 7, and 8 are kind of interesting, because instead of asking us to find a fourth point, they're asking us to prove or to verify whether or not something is a square. And so this is slightly different in the other sections, so this might have bothered you a little bit. I'll give you a hint. Basically what you're going to do, and you might want to do this if you're not sure, if you haven't done it yet, if maybe you skipped it to watch this video, what you're going to want to do is you're going to want to check distance formula, and you're going to want to check slope. What you're looking for is, are these rectangles and are these rhombuses? If they're both, then it's a square, okay? And so how do you do that? Well, if you do distance formula around the outside of the shape, and it turns out that all 4 sides are the same length, then you have a rhombus. And then you would do slope formula for 2 consecutive sides to show that they are negative reciprocals, or slopes are negative reciprocals of each other, to prove that it's a rectangle. And if you have both of those things, you have a square. So in number 5 dies right away, because you'll notice this length right here is not the same as this length right here. They don't match each other. So 5 does not equal 3. Number 5 is not actually a square. It might be a rectangle, and it is a rectangle, but it's not a square, and that's what the question was. So number 6 is interesting, kind of slanted a little bit. I've got it drawn up here. Notice my drawings aren't great. Yours don't have to be great. If you use the coordinates and you can put them into the formulas, the drawing doesn't have to be perfect. You can still see the answers. All my distances are the same, and my lines are perpendicular. Now, what I do here is I kind of look at the right triangle that's created by the side to look at the change. Notice I have a change of 2 and a change of 1. When I go up here, I should get the opposite of that. I should get the 2 here and the 1 here, and that's what happens. That lets me know, number 1, the distances are the same. I'm going to have 2 squared plus 1 squared for both of them. And it also lets me know that my slopes are going to be negative reciprocals of each other, okay? You'll see it again down here. When we get here, I'll show it to you. So number 7, distances are different. This one is parallelogram, but it is not a square. And you can find that pretty quickly using the values. Number 8, same idea that I talked about here. If you draw your little right triangle here and look at the change, okay, the change here, you're going to get a change of 4 versus, a change of 2 versus a change of 4. And then right here, you're going to get a change of 2 versus 4. You get the same values, only they're in opposite places. One of them it's an x and a y, the other one it's a y and an x as far as the 4 and the 2. What that tells me is that I'm going to get negative reciprocals. When I do my slope, I'm going to get a half here, and I'm going to get negative 2 here. Those are negative reciprocals. So my slope would be 1/2, and my other slope would be 2 over 1, but it would be negative. That checks out. That means that we are talking about a rectangle. Okay? And then when I look at my distances, remember these values from the distance formula are the same, or sorry, from the slope formula are the same ones used in the distance formula. So both of these are going to have 2 squared plus 1 squared. We take square root, the other one will be 1 squared plus 2 squared. And hopefully you can see that both of those, that would just get you square root of 5 and square root of 5. So they're the same distance, so they check out. So this one, number 8, is actually a square. All right. Number 9 is a generalization question. Hopefully you got a chance to kind of work through it. What they're wanting you to get to, though, is that if you have any square with any measurements such that the change is s, right? And it could be an a or an x or whatever you want. But if it's the same in both directions and you're trying to find that diagonal, think Pythagorean theorem. So here's my Pythagorean theorem, right? A squared plus b squared equals c squared. Well, a is s and b is s, so really I have s squared plus s squared. And then I'm going to take the square root of that. So I have the square root of 2s squared. That's an s. I know my handwriting's bad. I apologize. But this is 2s squared. And so if I had 2, let's put it here, just a little bit of room. If I have the square root of 2s squared, that's equal to the square root of 2 times s. And because the s shows up twice, I can write the s out front. S squared root of 2. So that is the answer they're looking for number 9. Okay? Hopefully that makes sense. The email is james.williams@fwisd if there's anything that doesn't. Now, let me give you your homework. I want to clear some space on the board. There's actually kind of a long homework assignment for this one. So let's clear some space right here and we'll make a list for you. So I'm going to give you problems on page 235 and 236. That's 235 and 236. We're looking at practice for activity 16. We're going to do questions number 1, question number 4, 5, 6, 7, 8, 10, 12, 16, and 17, okay? Now, hold up, what page was that? Hold on, Mr. Williams, I didn't catch the page. That is page number 235 through 236. This is the practice for activity 16, guys. It's been fun. Hopefully that makes sense to you. Do that practice, do that homework, and be ready for the next test, guys. We'll see you then. Thank you.